This question is looking for the stationary points. And to find the stationary points, we need to find the points at which dy by dx equals 0. So that is very important. Now, we don't have y in terms of x. We don't have y as a function of x. So it's not straightforward finding dy by dx. So we need to use implicit differentiation. That means we need to take each term and differentiate it. Okay, so it means we need to differentiate each of these separately. So to differentiate 5xy, let's just get this out of the way. So to differentiate 5xy, you'd need to treat this as a product. You need to treat it as 5x multiplied by y, and then use the product rule. So 5xy will give us 5x multiplied by dy by dx plus 5 multiplied by y. So I took the derivative, I took 5x as it is, and I multiplied by the derivative of y, which is just 1 times dy by dx. And then I took the derivative of 5x, and that's the 5, multiplied by the y with no change. So that's for the first term here. Now, to differentiate that, that's simply minus 4y cubed. But then I multiply by dy by dx. So that's the chain rule. So I do that because it's implicit differentiation, because that isn't x. Because it's y, you need to multiply by dy by dx. I next put the equal sign, and then I differentiate x squared to give me 2x, and then the derivative of 9 is simply 0. Okay, so the 0, no need to write that. So now what we're looking for is dy by dx, so we can make it equal to 0. So dy by dx is here and there. So any term that doesn't have dy by dx in it, I want to move to the other side. And anything that does have dy by dx in it, I want kept together. So on the right-hand side, I'm going to have 2x minus 5y. And on the left-hand side, I'm going to have dy by dx. Take a common factor, 5x minus 4y cubed. Okay, so what I did is I took this as a common factor. So that 5x is that, and that 4y cubed is there. Now, because we want dy by dx, we can divide both sides by that. So that then we can put there, and there we have dy by dx. So we found dy by dx, but that isn't enough. We want to say that dy by dx is equal to 0. So this is equal to 0. Let's add another page. So this is equal to 0. At the stationary point. is there one or more stationary points? The question says points, so it's likely that there'll be more than one solution. Now, when you have something divided by something equals to 0, the numerator has to be equal to 0. That's the only way to get the result 0. So 2x minus 5y equals 0. So x equals 5 over 2y. So that's my first achievement. I've managed to find x in terms of y. Now, that still hasn't found the stationary points for me. So we're still only slightly closer to the solution. So, but what I could do is go back to the original question and substitute x. So I could put this expression that I just found for x, and I could put that inside here. So I could replace each occurrence of x with 5 over 2y. So I'll have 5 times 5 over 2y times y minus y to the power 4 So I've just replaced my x's with that expression in terms of y. Now I have an expression or an equation with y only. The only unknown is y, so it should be easy enough to answer. Let's see what we can do. So 5 5's 25, and then y times y is y squared minus y to the power 4. Now we need to square the 5 and the 2, so that becomes 25 over 4 y squared plus 9. Okay, so it's looking a little bit better. So let's try moving everything to the right-hand side. So you have y to the power 4 plus 25 over 4 y squared minus 25 over 2 y squared plus 9 equals 0. So I basically took that to the right-hand side and that to the right-hand side, and I wrote it all on the left-hand side. So now I guess these two I can add or subtract. So 25 over 4 minus 25 over 2 is minus 25 over 4. And if I multiply everything by 4, I'll get 4y to the power 4 minus 100 y squared plus 36 equals 0. So this is a quadratic equation. Let me just see, can I factorize this? Because basically we want to, it looks like it's a quadratic in terms of y squared. I'm not sure I can factorize it, so I can say if you take A as 4, B as minus 100, and C as 36, you can say y squared equals negative B, that's positive 100, plus or minus square root of B squared minus 4ac. All of that divided by 2 times 4. So that will give me y squared equals, if I just reach for a calculator, now that it didn't give me an exact number, so I'm going to have to do it step by step. So 100 squared is 10,000, and minus 16 times 36. That gives me, 100 plus or minus 4 square root of 589 over 8. And we can simplify that if we divide by 4. So y squared is 25 plus minus square root of 589 over 2. So basically, I divided numerator and denominator by 4. So that's my final answer for y squared. Y would be a square root of that. So y would be square root of what we just found. Okay, so, and again, I think it's possible to have positive or negative. So there's a total of 4 values for x, 4 values for y, and consequently 4 values for x, because x is 5 over 2 times y. So there's going to be 4 values for x, 4 values for y. So strictly speaking, I guess, because the question said find the exact coordinates of these points, we're going to have to find those one by one. So here goes. Let's change the color and say y1. So basically it's going to be four versions of this. So let's just put that there, shrink it a little, change the color. So let the first y be positive, positive. The next y will be positive, negative. So that will be negative there. And the next one will be minus plus. So that's y1, y2, y3, and y4 will be negative, negative. So negative outside and negative inside. So the difference between all these y's are the signs next to the square roots. So now you have 4 values for y. You're going to need 4 values for x. And remember, x is 5 over 2 times y. So x1 is 5 over 2 times this. We don't need the plus sign. And we just repeat that 4 times. x1, x2, x3. I hope the answer is correct because I'm not repeating this. x4. 1, 2, 3, 4. Positive, negative. And then here we've got negative. And finally, we've got negative, negative. Good. So the question said, find the coordinates of the stationary points. Here they are. x1, y1, x2, y2, etc. How did we do it? Well, it was implicit differentiation. After we realized we needed to find the points where dy by dx equals 0, the key was implicit differentiation. We used the product rule here. Then we did a bit of rearranging. Then we took the numerator to be 0 at the stationary points. Then we found x in terms of y, substituted back in the original equation. We simplified until we got something that looked a little bit like a quadratic. I mean, you might say, oh, that's not a quadratic. Well, it's a quadratic if you remember that y squared is y to the power 4. That gives you that. And then to find y, you need the square root of that. So we have this silly looking expression where you have a surd under a surd. But the question did say exact. And that means we need to leave these surds. So we found the y's and the corresponding values of x simply by substitution. So I hope you found that helpful.